Okay, 2-4 part 2. Okay, fundamental theorem of algebra. A polynomial function of degree n has exactly n zeros, including repeated zeros in the complex number system. So what it means is, if highest power of x is n, then we will have exactly n solutions, n zeros, including imaginary number. Linear factorization theorem. If you have zeros as a C1, C2, C3, and all that, you can write that as a factored form. Okay, it's easier with the example, so let me just move on. So example 6. Write a polynomial function of least degree with a real coefficients in standard form that has -1, 2, and 2 minus 1 as zeros. So I gave you 3 zeros, which is -1, 2, 2 minus I. Okay, given zeros, you should be able to write the factors. To get the -1, you should have x plus 1 as a factor. So you might say, why is that? Well, so when you solve for 0, you let that equal to 0. Solve for x -1, -1, so x equal to -1. So you will end up with a -1. So you get the 0 as a -1 if you have a factor of this. If you get the 0 as a 2, you should have x minus 2 as a factor for the same reason. If you have x minus 2 as a factor, you can do x minus 2 equal to 0, solve for x, plus 2 both sides, you will end up with 0 as a 2. Now, this is not so simple. So for applying same logic, you want to do this as x minus this whole thing, you need a parenthesis, 2 minus I. Okay? Here's your one more catch. When you have a 0 of imaginary number, each complex conjugate is also 0. Complex conjugate means change sign for I. So when I give you 1, 2, 3 zeros, since this is imaginary number, 2 plus I is also 0. Even though I did not specify, if this is a 0, that goes together. As a couple, they always goes together. They call that as complex conjugate. If one is 0, the other one has to go. So knowing that, you should have another factor of x minus that whole thing, which is 2 plus I. So we got 1, 2, 3, 4 factors. All you have to do, distribute them out. So here, once you figure them out, x plus 1 times x minus 2 times x minus parenthesis times x minus parenthesis. We have to distribute them. Okay, so let's deal with this nested parenthesis first. I'm gonna show you 2 different ways. You do whatever is easier for you. Okay. So one thing you can do. So I'm trying to distribute these guys. So let me just work on that part. You can just get rid of the parentheses inside by distributing -1, distributing -1. So it becomes x minus 2 plus I, x distribute -1, -2 minus I. Okay, so you can keep this one for now. We will deal with that later. So all you have to do is just distribute. So I'm going to distribute this 4 here. X times x is x squared, x times -2, x times 1, 1 times -2. Okay, I'm going to distribute these two. Okay, I strongly recommend you to don't mix them up. If you try to distribute like that, nothing wrong with it. You're going to create complete chaos. Don't do it. You rather distribute this one by themselves and distribute these by themselves first. So here are some options I'm going to show you. Option number 1, just distribute. X times x, x times minus 2, x times minus I, time to distribute minus 2. Minus 2 times x, minus 2 times minus 2, minus 2 times minus I, time to distribute I. I times x, I times minus 2, I times minus I. Okay, be careful. I times minus I is minus I squared, minus I squared. Do you remember what I squared is? I squared equal to minus 1. If you forgot that, now you know. So minus I squared is minus 1. So minus 1 is positive 1. So that becomes a positive 1 here. Okay? Okay, so if you look at this guy, x squared is x squared. Let's look at the, do you see here? Minus ix plus ix, they cancels out. Do you see you have a plus 2i minus 2i cancels out? Minus 2x, that becomes minus 4x. Do you remember minus I squared was plus 1? So plus 1 plus 4, that becomes a plus 5. Okay? Now you combine like term here, that becomes x squared minus x minus 2, minus 2 plus 1. Now you just distribute all that, then you will get the final answer. So let me just finish that. So we're going to distribute that. That should be what? X and x squared, that should be x to the fourth. X squared minus 4x minus 4x to the third. X squared plus 5x squared. Minus x squared minus x to the cubic. Minus x minus 4x plus 4x squared. Minus x plus 5 minus 5x. Minus 2x squared minus 2x squared, minus 2 minus 4x plus 8x, minus 2 plus 5 minus 10, combine like term. X to the fourth, cubic. I got minus 4 minus 1 minus 5 x to the cubic, square. 5, 4 minus 2. So 5, 4, that's a 9. 7 7x squared, x here plus 3x minus 10. Okay, did I get the correct answer? X, yeah, that's the one. A lot of work, huh? Okay, let me share. So if you follow through this, you like this method, stick to it. Here's a one thing you can do. You may like it, you may not like it. Right here, once you distribute, this is a one thing you can do. You can parenthesize this first two terms like that. Here to here, here to here. I just parenthesize the top first two. Then it becomes a plus b, a minus b form. If you recognize that, that's a squared minus b squared. So what I'm trying to say is this is the same as x minus 2 squared minus I squared. If you see that structure, then all you have to do is just square this, which is x minus 2, that's x squared minus 2x plus 4, which is x squared minus 4x plus 4. I squared, do you remember, which is minus 1? So that's minus 1, minus 1, that's plus 1. So you get plus 1, plus 1, plus 1. So you get x squared minus 4x plus 5, and that's what you get. So I say that's a lot more elegant way less work to get this. But number of my students, they prefer this. Which one I think it's just less headache. If I just straightforward, just distribute all that, combine like term, I prefer that way. So I wouldn't say anything is better than the other, because this could be a little tricky to execute. So do whatever is easier for you. Okay, you should pause the video. Please try this. Okay, I already did the work here. -2 multiplicity 2. So -2 here. You might say zeros, -2, 0, 3i. So hopefully you still remember. Even though I gave you 1 0 of imaginary number, each complex conjugate comes automatically. So 3i, change the sign of I, so it's -3i automatically comes together. So you got x -2, so factor should be x plus 2. Be careful, because they said -2 has a multiplicity of 2. What does that mean? You get -2 twice. So you gotta have a square. Multiplicity 2, that means you have the second power. 0, to get the 0, you have to have x minus 0. X minus 0, which is same as just x. Okay? And to get the 3i, you need x minus 3i. To get minus 3i, you need x plus 3i. So if you can set it up, now all you have to do is multiply them. X times parenthesis x plus 2 square, this times this. Okay? So I did x plus 2, x plus 2. I distribute that, I got this. I fold this, okay? X times x times this, x times this, okay? So if you do this, that's a plus 3ix. That's minus 3ix, and they cancel out each other. That's why I don't have that. So x times x is x squared, minus 3i plus 3i. If you multiply that with minus 9, I squared is minus 1. So minus 9 times minus 1 gives you positive 9. So I distribute that, I got this. I got distribute this, I got this. From there, I'm just distributing all that here. Distribute, combine like term, I distribute x all the way. That's the final answer. Okay, factoring polynomial functions over the wheels. Every polynomial function of degree n greater than 0 with the real coefficients can be written as a product of linear factors and irreducible quadratic factors. Okay, so we have this example here. Consider this. Write k of x as a product of linear and irreducible quadratic factors. So if you do try all possible rational zeros, you get a whole bunch of this. The original polynomial has a one-sign variation. So if you sketch this using graphing calculator, you get something like this. What are you interested in? You are interested in nice zeros, the integer zeros. So it looks like we got right here 1, 2, 3, 4. You got 4 as a 0. You got one more, -2 and -3. Okay? So when you graph it using calculator, you got a bunch of the zeros. So the one your graph shows is a 4. I got 4 here. I got -2 here. I got -3 here. So that's really good. So you can try to do synthetic division with those. They here. Did they do it? Yes. I can show that to you. Might be easier. So 5, third, fourth, third, second, first. So what you want to do here is, so start with 1, 1, -13, -23, -14, -24. And we already figured that out. That one is going to be working, right? So from the graph, you already know that's going to be the 0. So you know that's going to work. So I'm going to try with the 4, adding, multiplying, adding, multiplying, adding, multiplying, adding, multiply, add, multiply. You are supposed to get 0. Okay? Okay, so we cleared 4. Do you remember? You can keep going with leftovers. That's less work for you. So I'm going to continue here with the -2. This is gondo. You only have to do with this. Adding, multiplying, adding, multiplying, adding, multiplying, adding, multiplying, adding, 0. So -2 works as well. It is supposed to work. We already verified from the graph. -3, you gotta keep going with the -3. So I'm gonna go with the -3, adding, nothing to add, multiply, adding, multiplying, adding, multiplying, adding. Okay. So we got 0, 0, 0, everything is good, so we cleared this. Now, left over to this, if you write it down, that's gonna be, leave that alone, and put an x there, put an x squared there. So you got x squared, 0 times x is just 0, x squared plus 1 will be left over. And if you try to factor this, it's not gonna work. Okay? So we have linear factors we're looking for. Because we got the zeros as a 4, -2, -3, which means we can write down x minus 4 from 4. We can write down x plus 2 from -2. We can write down x plus 3 from -3. And at the end, we got the leftover, which is x squared plus 1. And that is the answer they are looking for. So x minus 4, x plus 2, x plus 1, x squared plus 1. Okay? Okay, now what? Following question says, write that as a linear factors. Linear factors. The factor we got was all linear here. That wasn't linear. So when they ask you to the linear factor, you actually have to split this further. So here's what you can do. You can look at x squared plus 1 as x squared minus 1. And -1, you remember I squared equal to -1. So you can interpret it as x squared minus -1 is same as I squared. Then you can apply a squared minus b squared form is equal to a plus b, a minus b. So you can interpret it as x plus I, x minus I. So you are keeping all the other as it is. Only this part you're factoring further as x plus I, x minus I. So that will be final answer. Okay. So we only factor further of x squared plus 1 with x plus I, x minus I. That's going to be the answer for B. Okay, C. List all the zeros of kx. Okay, when they say all zeros, they do mean everything. including I. So we had the zeros already, okay? But we have to include the imaginary zero as well. So we got 4 minus 2 minus 3 there available. So from here, you can say x plus I equal to 0, x minus I equal to 0. So for x, so minus I both sides, x equal to minus I, plus I both sides, x equal to I. So we got 2 more imaginary zeros. So be careful. List all zeros meaning everything, including imaginary number.